Hello dear students and my friends, welcome to Karna Maths Academy. Today in this lecture we are going to discuss derivative from first principle. Already we have discussed question number 1 and now we are going to discuss question number 2. Question number 2 is find from first principle the derivative of 1 by root x. So this is one of the important question which is frequently asked in the secondary board examinations. Solution: let y is equal to 1 by root x. The given function is 1 by root x. So let's suppose y is equal to 1 by root x. And we will find the derivative of the function 1 by root x by using the first principle, derivative from first principle. The first step of the derivative from first principle is we have to add delta x and delta y in x and y respectively. Let delta x and delta y be small increments in x and y respectively. We have to add delta x and delta y to both sides. That means we have to add delta y in y and we have to add delta x in x. Then we'll get the second function, or we can say second equation. Y plus delta y is equal to 1 by x plus delta x. Increasing y in the given function, increasing y by small increment delta y and increasing x by the small increment delta x. Then we get y plus delta y is equal to 1 by root x plus delta x, which is the second function, or we can say equation 2. Now by solving the first and second equation, we'll find out the value of delta y. To get the value of delta y, we have to subtract equation 1 from equation 2. Subtracting equation 1 from equation 2, we get y plus delta y minus y plus delta y minus y equals to 1 by root x plus delta x minus 1 by root x. Plus y minus y will cancel, we get value of delta y. The value of delta y is equal to, now taking the LCM, root x plus delta x into root x. Taking the LCM, then we get root x into 1, root x minus root x plus delta x into 1, root x plus delta x. So after taking the LCM, the value of delta y, we get root x minus root x plus delta x by root x plus delta x into root x. Next, we multiply by the conjugate of numerator in order to simplify, change into simple form. Root x minus root x plus delta x, the conjugate of the numerator is root x plus delta x. While taking conjugate, we have to take the opposite sign. If there is minus, then in conjugate, we have to take plus sign. So multiplying and dividing by the conjugate of numerator, that means the conjugate of root x minus root x plus delta x, which is root x plus delta x divided by root x plus delta x. Because we cannot find the derivative, when we take limit delta x tends to 0, then the given function takes 0 by 0 form, which is indeterminate form. So we are not able to find the derivative of a given function directly, because when we take limit delta x tends to 0, then the given function will take the form of 0 by 0, which is called indeterminate form. That is why we have to multiply by the conjugate of numerator, so that the indeterminate form will easily eliminate. Now when we multiply by the conjugate, then the numerator, that means root x minus root x plus delta x into root x plus delta x. They are in the form of a plus b into a minus b. A plus b into a minus b is a square minus a into a square minus b square. Root x square minus root x plus delta x square. Now square and root will cancel. Then we get x minus square and root will cancel, minus x plus delta x, which is equal to delta y is equal to x minus x, multiplying the second term by minus sign, minus x minus plus minus delta x. So we get x minus delta x, plus x and minus x will cancel. The terms of the denominator keeping as it is. Delta y is equal to minus delta x by root x plus delta x into root x bracket root x plus delta x. Now to cancel delta x or to remove 0 by 0 form, we have to divide both sides by delta x. We have to divide both sides by delta x, so that delta x will cancel and the form of 0 by 0 will be eliminated. So dividing both sides by delta x and taking limit delta x tends to 0. So this is the second step of derivative from the first principle. After finding the value of delta y, we have to divide by delta x on both sides and take limit delta x tends to 0. Dividing both sides by delta x and taking limit delta x tends to 0, we get limit delta x tends to 0, delta y by delta x equals to limit delta x tends to 0 minus delta x dividing by delta x, root x plus delta x into root x bracket root x plus delta x. So keeping the other terms as it is and dividing by delta x on both sides. Now according to the definition of derivative of any function is the limiting value of delta y by delta x when delta x tends to 0. Therefore we can write limit delta x tends to 0, delta y by delta x is equal to dy by dx. So this is according to the definition of derivative. Derivative is the limiting function of delta y by delta x when delta x tends to 0, where delta x and delta y are the small increments in the given function in x and y respectively. Limit, take limit on both. Limit delta x tends 0, delta x will cancel, then we get minus 1 by other terms keeping as it is, equals our dy by dx is equal to, now putting the value of delta x 0, because 0 by 0 form has been eliminated, so putting the value of delta x 0, x plus 0, other terms as it is, putting the value of delta x 0, then we get dy by dx is equal to minus 1 by root x into root x plus root x, root x plus root x is 2 root x, and root x into root x is root x whole square, a square and root will cancel, then we get dy by dx is equal to minus 1 by x, square and root cancel, so we get minus 1 by x into 2 root x. Now x as it is, root x means x power 1 by 2, so multiplying x and root x, so by using the multiplication rule we have to add the powers, so x power is 1 and x power is 1, 1 plus 1 by 2, we get x power 1 plus 1 by 2, that means x power 3 by 2, therefore dy by dx is equal to minus 1 by 2 into x power 3 by 2. Hence the derivative of the given function y is equal to the given function 1 by root x from first principle is minus 1 by 2 into x by 3 by 2. Therefore, the derivative of 1 by root x is equal to minus 1 by 2 x power 3 by 2, which is the required answer. Thank you. Thanks for watching. If you like this video, please subscribe and share it to your friends. Thank you.